Good day, guys. Welcome to Achievement Tech Academy. Today we'll be looking at how to calculate RMS value for sinusoidal waveforms and harmonic. Okay, so when we are given a sine equation like this, we'll have to first of all, how do we calculate the RMS value? We simply calculate the RMS value by taking the maximum value, this value that I've circled, the Vm, and we simply divide it by root 2. That is how we calculate the RMS value. So to calculate the RMS value of this, we simply use this formula, the Vm. We took the Vm divided by the square root of 2. And we can also represent it as this if it is a current, or if it is a current, this was a voltage, this is a current. So how do we also calculate for this? We also do the same. We take the maximum value and we divide it by root 2. So this is how we simply calculate the RMS value for sine waves. So I would want us to take some examples, then we'll see how to use the formulas. So our example says we should find the values of the following quantities. Um, for the I, how do we find it? We realize that our maximum value is 10 over root 2, and we were already given a formula that to find the current, the RMS value, we simply divide the maximum value by root 2. So how do we do that? So doing that for A, we simply divide it by root 2. Dividing it by root 2, realize that the 2 and 2 will cancel out, this and this will cancel out. Then we have our 10. So here, our RMS value becomes 10. And for the B, we realize that it's just the maximum value is 20. Then we also divide it by the square root of 20. Then we have an answer of 14.14. So this is how we simply calculate the RMS value of sinusoidal waveforms. So I will give you an assignment, and this is your assignment. So please solve this. Find the RMS value of the following quantities and leave your answer in the comment section. So I'll come to the comment sections and mark. Those that will get it right, I will give you airtime for that. So kindly leave your answer in the comment section. Okay, now we want to look at how we also calculate the RMS value of harmonics. Um, we realize that with sine waves, we simply divided the maximum value by 2. But how this is a harmonic equation, the whole of this. When you see something like this, it's a harmonic. You realize that the frequency keeps on increasing. You see, this is the frequency. It keeps on increasing. Here it was WT, here it became 2 WT, and here it became 3 WT. So when you are given a question like this, how do you calculate it? And here we just realize that this is a DC component, the A naught. So here we realize that this one, um, the frequencies keep on increasing, but we realize that this is a sine wave, this is a sine wave, this is a sine wave, right? Sine waveform. So how do we convert sine waveforms? We just divide the maximum value by root 2, right? So we simply do the same thing here. So we just bring our big square root. Then this one is just a DC quantity, so it becomes A naught square. So by here it will become the A divided by root 2, then you just do that true. So this is the formula we use. You see, we square it, we square them. So here A naught square, you see, this is a DC component, that's why we just did our A naught square. And here this is a sinusoidal quantity, that's why we just use our formula, A1 divided by the square root, and we square it. So to calculate the harmonics, you just square them throughout. You realize that these are just sine waves that I'm just converting them and squaring them. So this is how we calculate the RMS value of a harmonic waveform. So I want to take an example, then we'll use it to understand. So in this question, they are saying we should find the RMS value of this waveform. So realize that what we will simply do here is to find the RMS value. We can say our I here is equals to, this is the 2 is a DC component, so it becomes 2 square plus our 5 over root 2 all square plus our 3 root 2 all over root 2 all square, and plus, that's all divided by all square root. So this is how we simply calculate for it. So doing this, we end up getting our final answer as our 5.05. So this is how we calculate the RMS value of a harmonic waveform. So this place is just a formula work. So please kindly take your time, go through, and uh, it will really go a long way to help you. Thank you very much for watching. So please remember to share this video, like, subscribe for more content, please. And I'll be marking the assignments in the comment section. The one who gets the right answer, I'll give you an airtime. Take good care of yourself. I'm signing out.